like recently she's been like fighting people if they like put their hand too close to her. She hasn't really been chewing on like things.
Well, that's good then. Our friend's puppy, I guess, has started to like chew everything in the house, so they can't leave her unattended. So she either like gets locked up in her crate and then she barks and whines and cries, or you have to like follow her around. And I feel like you just need like a pen, like cage them in a pen.
That we have something like that.
Do you? Does he or she
She
bark and whine and cry when she's in it?
Not most of the time.
No? Okay.
Although most of the time she's just in either my mom or her sister's room, like when my dad does work or whatever.
Okay. Like we're good. Good morning. Good morning, everybody at home.
Morning.
I appreciate you responding so that I know that you're there and that you can hear me too. That's good. So, oh, Jeremy wants in. Sorry, I should lock my screen. We're going to wrap up the first half of the chapter today by finishing our discussion on reference angles, finding angle values in radians and degrees, and we will look at a couple of the homework problems from last night as well. We're going to kind of do those last. So I have a warm-up that we're going to look at with graphing reference angles. And just talking about those reference angles and the values of those angles for the trig function, sine, cosine, and tangent on a unit circle. And then we'll kind of look at a couple of problems where we, again, work on finding the angle value when you're given like the cosine is the square root of 2/2 like we did yesterday. So today and tomorrow, we'll review worksheet today. There's a worksheet number 1 in your packet. And then tomorrow there's worksheet number 2. The answers are on today's worksheet at the very bottom of the worksheet. And then tomorrow the answers will be posted in the assignment in Google Classroom. But, oh, thanks. Thank you. Thank you. Here we go. Just a couple of things about this week and next week. So this week is the end of the marking period. Thursday is the end of the marking period. And then next week is the beginning of the 3rd marking period, which I can't believe we're here already. Like it really does seem like it's gone pretty quickly. We're half a year's done, which I don't know. I think it's flown, but maybe because we've been like in so many different phases of school and it just seems to go quicker that way, bouncing back and forth. But you have a midterm coming up. Peter's like, say what? Midterm? Traditionally, we give the midterm after chapter 4. We're usually done with chapter 4 the 3rd week of January. We're only halfway through chapter 4. And the second half of chapter 4 is about 4 more weeks. And if I wait until the end of February to give a midterm, it kind of just seems like it's not the time to be giving a midterm. So we are going to, Mrs. Robleski and I, the other honors trig and pre-calc teacher, kind of talked about what we should do. And we're giving a modified midterm for the first half of the class, because really when you get to the end of the first marking period or the first semester, it is like pretty much half the class. So it'll be on chapters 1 through the first half of 4. And we're going to review next week, next Tuesday, Wednesday, and Thursday. Those of you in class next Friday will take half of it. Those of you at home next Friday will take it as well. And then on Monday, we'll take the other half. There's 15 questions each day. So it's a 2-day midterm, so next Friday and the following Monday. And it will be equal because you each will be taking a part of it in class, and then the other group will be taking it then the following. So it'll be fair that everybody gets to take one part at home and one part in school. Cool.
Last year, didn't we have like 50 questions per day?
Yes.
So,
Yes, so it is still multiple choice, but if you think compared to last year and the like problems we're doing this year, I mean, like the problems this year, you contain a lot more material. So one problem, I can kind of assess you on a couple of different things. So there are 15 good problems. Some of them are pretty quick, straightforward. And I went through and I modified it. I changed it from midterm that I gave like the previous couple of years to kind of go along with the concepts that we've been working on. But yeah, so yes, cool. A lot shorter than last year's. The questions are a little more involved though. Does anybody have questions with that? Sorry to surprise you. I forgot to tell you yesterday, but I mean, better to tell you today. Peter was surprised, I think. So it's multiple choice. It's on Google Forms. I think it should be okay. Any questions at home on that? Anybody at home surprised? No, everybody was expecting it at home, I guess. All right, so I'm gonna pull up a warm-up. This warm-up was, I wanted to use it as an exit ticket yesterday and I decided not to. You do not have to pull this up on Google Classroom. If you don't want to, you can just kind of have a piece of paper or a blank screen in your packet, like just add an extra screen in your packet if you want to do that. And you can just add these problems somewhere. So this is a little review of what we were working on yesterday with reference angles. Here it is. So again, find a blank, add an extra screen, add an extra slide in the notes packet. Write them on a piece of paper, just to kind of review a reference angle. Find the reference angle for each of the following. If it's given in radians, keep it in radians. If it's given in degrees, keep it in degrees. And that's how your test will be on Thursday. However the angle is given, your answer should kind of replicate the measurement of the angle, if it's measured in degrees or if it's measured in radians. So our first angle is negative 480 degrees. It's degrees, so keep it in degrees. The second angle is 15 pi over 4. Again, that's radians, so keep it in radians. So find the reference angle for each of the following. And it might help to draw a little sketch. So think about negative 480 degrees. This is a nice little review of sketching bigger angles as well. So that angle is definitely larger than 360 or 2 pi. Nice review of sketching an angle or finding the location of that angle, which quadrant does it lie in. So Jack, if it's a negative angle, it rotates clockwise. Yeah, so if we go all the way around, we know that's 360. But we have to go to negative 480. So Jack, where would negative 480 be? Yeah. So if I go all the way around, negative 480 plus 360 would be all the way around. I'm now at negative 120 degrees. So that's the amount that I need to continue to go around and get into the third quadrant. That's the extra amount after I go around the whole circle. Our goal is to find the reference angle, which remember is the angle that takes us, connects the x-axis and the terminal side. And we said yesterday that was theta prime. Cool. Yeah, go for it. Yeah, so you need to take 180 minus the 120 degrees that we have left. And Cole, that answer is 60 degrees. Nice job. So that reference angle is 60 degrees. We would then use that reference angle to find the ordered pair and then to get sine, cosine, and tangent, secant, cosecant, and cotangent. So get the location, how far beyond 360 did you go, and then take that number minus 180. The second one is in radians, so we want to keep it in radians. I divided half of my pie, half of my circle, into 4 pieces or 4 parts, and then the bottom half, because it's pi divided by 4, so half the circle divided by 4. And then if you sketch 15 pi over 4, Leah, where did you get 15 pi over 4? Say it again. 4th quadrant. So we have, there's 8, 9, 10, 11, 12, 13, 14, 15. So that would be the angle. Leah, that means the reference angle is, yeah, pi over 4. And we said yesterday, like when it's in radians, the reference angle is whatever the denominator is. So the reference angle for radians is really easy to find. So it would just be pi over 4. So whatever the denominator is the reference angle, pi over 6, pi over 3, pi over 4. The other part here, I will say that you will see this exact chart on the test on Thursday. Hopefully it's easy values for you to kind of fill in here, but you don't have to copy this chart down completely. Maybe just make yourself a note so that you know that you will see something like this and that you need to kind of be able to find the values of sine, cosine, and tangent for acute angles. So these are pretty much all of the reference angles, the angles that lie in the first quadrant. If I have an angle of 0 degrees, it's also 0 radians. If I have an angle of 30 degrees, Joe, what's 30 degrees as a radian? 45 degrees is? And 60? Finally, 90 degrees. Yeah. Notice the denominator gets smaller as the angle gets larger. And that's how fractions work. The smaller that you divide by, your number should be bigger. So that's why it corresponds with a bigger angle. Remember that sine is y and cosine is x. The tangent is y over x when you're on the unit circle. And then you can kind of fill in those values. So if you need to write the ordered pairs somewhere, you can feel free to do that. Maybe I'll write them on the side just so you have them here. So you're taking the ordered pair from the unit circle. Sorry, mine's sloppy. It's a lot harder to hold an iPad and write while you're standing than it is sitting and writing on the iPad. But I feel like I sit so much, so standing sometimes is a little better, but my handwriting is a little sloppier. Any questions on that? Kind of getting those ordered pairs. So when you're looking at the ordered pairs, root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2. They kind of flip-flop as they're going down. 0 degrees and 90 degrees are the opposites of each other as well. So just a little review. Pretty much everything in the unit circle is associated with this chart. All you need to know is the first quadrant angles, and that's what those reference angles we're talking about. Any questions? Anybody at home have questions? So we are going to look at, I believe, 2 examples in your packet. The final section 4.4, it's day 3. We're not going to do all of the notes. I'm going to kind of skip around. But there is one more section that we're going to look at, or one more part that we're going to look at. And then we will go back, and I have a couple of questions from the homework that I want to talk about. There was actually a good number of homework problems, questions on the daily homework form, so I do want to go over those, but we'll kind of hit them last. So the warm-up question wants you to evaluate using your calculator, and this is page 35 in the packet. So if you want to pull out a calculator, just a little refresher because it's been a little while since we've actually gone to the calculator and tried to evaluate functions in the calculator.
On the homework last night, there was like something like this, and for like cotangent, why couldn't you do, like, why don't you do it as a second tangent? It didn't work.
Because that's finding the inverse and their reciprocals, not inverses.
Okay.
So that's why. So when you hit the second tangent, you're finding the angle, but we already know the angle.
Okay.
So anytime you hit the second button of sine, cosine, and tangent, the goal of that function is to find the angle value.
When I put like just like tangent of 4, we'll say 410, and then I put that to the -110, it worked.
Yes, I mean, it might, because there might be still an angle value for that number. So when you're using your calculator, we know that the cotangent is equal to what? What's the reciprocal of the cotangent? 1 over tangent. So to plug this in the calculator, 1, you need to have degrees because it's a degree angle. And then the second thing, you need to plug it in as its reciprocal because they're reciprocal functions. So the cotangent is 1 over the tangent of 410 degrees. So go to the calculator, make sure your mode says degrees, which mine currently says radians. And then I'm taking 1 divided by the tangent and then 410. And then when you hit enter, you should get a number here, a decimal value. 0.839 is what my calculator is telling me. And again, that is the answer. That's the value of the trig function because you know the angle. So you're plugging in the angle because we know what the angle value is. Questions with that? So the second one said cosecant, I think. So it says cosecant -7. So Cole, the cosecant is reciprocals with, yeah, so 1 over the sine of -7. Is that -7 radians or degrees? Radians, because it doesn't have a degree symbol. So if there isn't a unit, it's implied to be radians. So again, go back to the calculator, switch it to be radians. So change your mode back to radians. And then 1 divided by the sine of 7. It is +7, right? Oh, -7. Okay, thank you. And then I get -1.522. So there were 2 questions maybe on your homework that were similar to that. And you have to first convert it to the reciprocal function because you know the angle. So you're taking 1 over its reciprocal. Questions? Okay, any questions with that? All right, so let's look at the second problem. Some of your homework was similar to this second problem. So we talked about a little bit this type of problem on Friday. We did a little bit of this type of problem yesterday, and we're going to do it one more time. And then I have a problem from the homework that we'll go over as well. So this says, given the cotangent is -3, and your angle is in the quadrant 2. Find the other 5 trig functions. Draw a right triangle in the appropriate quadrant. You will be asked to sketch a right triangle in the correct location to model the situation that you're given. All right, so let's get an XY axis going here. We know the cotangent is -3. So without doing any work, without even drawing a triangle, Jack, what other function can I find if I know the cotangent? So if the cotangent is -3, the tangent is, yeah, -1/3. So you flip it, and without doing any work, I know tangent because they're reciprocals. We also know that tangent is y/x. So let's look at the second part. It says the angle is in the second quadrant. So when the angle is in the second quadrant, our triangle comes out of the origin because it has to start in standard position, and it connects down to the x-axis because we need to use that little reference angle. So it always connects to the x-axis. Jack, if you're in the second quadrant, is your x or y negative in the second quadrant? X is negative. So when we have this -1/3, the x is the negative. So that really creates an ordered pair of -3, 1. So when I go to label my triangle, the x, I'm moving over -3. The y is up 1. Question?
Do you use like, since it's, you have the tangent or the cotangent of -3/1, you do adjacent over opposite.
Yes, you could do that as well. Yep. So it's the same thought process. So you could say that the tangent is x over y, or I'm sorry, cotangent is x over y. It's also the adjacent over the opposite. You could think of it as y over x for the tangent or opposite over adjacent. So there's a couple of different ways for you to think about how to label the triangle. We need to find the hypotenuse or the radius because really there is a circle going around this. That ordered pair -3, 1 is the point on the edge of the circle. So a couple of different ways that you can kind of think about what you're finding. So I have a -3, I need to square it. Don't forget you're squaring the negative and the 3. We got a 1, we're squaring it. That makes our radius squared, or it makes c squared. And that gives us the square root of 10 for the hypotenuse. So opposite over adjacent, y over x, the radius and the hypotenuse are the same value as well. Once you have it labeled, then you're finding the other trig functions, which mean we still have to find sine and cosine. And we have to find cosecant and secant. So a couple of different ways to think about it. So if I want to get the sine is the opposite over the hypotenuse, or it's y over r. Well, that's 1 over root 10, which is root 10 over 10. It's positive because it's y. Y is positive in the second quadrant. The cosecant is the reciprocal of sine. Well, 1 over root 10 was sine, so the cosecant is just root 10. The cosine is x over r, or adjacent over hypotenuse. Well, my adjacent side is -3, the hypotenuse is 10. That should be negative because it contains an x. If I simplify that, I get -3 root 10 over 10. And then the secant would be negative root 10 over 3 because it's the reciprocals with the cosine, or it's r over x. So I now have 1, 2, 3, 4, and that guy makes 5 trig functions. But when you are given a value and it is not a number on the unit circle, it's not a value from that warm-up that we just did. It's not one of the numbers in the ordered pair. It's not a 1/2. It's not a square root of 3 over 2. It's not a square root of 2 over 2. Then you need to make a triangle because it's not a number on the unit circle. So that would be like 81 and 83, which we'll go over in a minute. The last problem we're going to do, I said we were going to skip around. We are going to skip example 2. We're going to skip example 3. We're going to go all the way down to example 4, part C. So we just skipped a whole bunch. Example 4, part C says use the calculator and your trig knowledge to solve the following. Round to 3 decimal places if necessary. We might not have to round to 3 decimal places. If you look at part C, we have the cosine of theta equals -1/2. And let's just worry about that right now. What part of the equation are you solving for, Peter? The angle. So we don't know the angle. We need to find the angle or find theta. They're telling us that the angle should be in degrees. So we're going to try and find this angle in degrees. We did these problems yesterday, and you had a few on your homework. We're going to see if we can kind of go through this one again. So when you have cosine, cosine is x or y on the unit circle. Cosine is x. -1/2 is a value for x on the unit circle. So because this is a number on the unit circle, I'm going to use the information for the unit circle to help solve it. So 1/2 is part of an ordered pair on the unit circle. So like we did yesterday, we're going to first think about that 1/2. Cole said it was x. If x is 1/2, what's its matching y value to create an ordered pair that would be on the unit circle? Peter? Square root of 3/2. So that would be the ordered pair on the unit circle. Before we go and kind of think about this, what angle in degrees, Peter, has an ordered pair of 1/2 and square root of 3/2? Flip it, 60 degrees. So that's a 60-degree angle. So we are going to try and use this information, and it says, and your trig knowledge, to try and find an angle for cosine that matches it to be -1/2. So Joe, where is x a negative value in a quadrant? So what quadrant would x be negative in? The second quadrant. So x is negative in the second quadrant. So in the second quadrant, I would have the ordered pair -1/2 and the square root of 3/2, because x is negative in the second quadrant. I know that that angle has to deal with a 60-degree angle. Our goal is to figure out what that angle would be in the second quadrant. And the way we do that is by using this 60 degrees as our reference angle. So that's how reference angles help us find values for functions. The reference angle 60 degrees is the other half of that angle. So the angle, Peter, would be, say it again, 120 degrees. Did you have a question?
Yeah. How do you know that the reference angle is 60? Is it from the?
It's from this ordered pair. So the 1/2 square root of 3/2. So because x is 1/2, square root of 3/2 is the matching y value. And because of that ordered pair, that makes our reference angle. Good question. I'm sure other people have that same question. So we're first looking at cosine and saying we have cosine is 1/2. Ignore the negative. The y value when x is 1/2 is the square root of 3/2. That ordered pair is a 60-degree angle. That angle is a reference angle. Any angle less than 90 degrees is a reference angle. So now I have an angle at 120. Where else would cosine have a negative x? Or where else is x negative? In the third quadrant, x is still negative, but y is also negative. So cosine is -1/2 in the first quadrant, but cosine is also -1/2, I'm sorry, in the second quadrant. It's also -1/2 in the third quadrant. That same 60 degrees is going to take us to the angle in the third quadrant. So here's 180. My second quadrant angle was less than 180. The angle in the third quadrant has to be more than 180. So Cole, if I'm at 180 and I go 60 degrees more than it, we would be at 240. So my angle of 120 and 240 degrees is when the cosine is equal to -1/2. Questions? Now, the second part of this, if you look at the notation, we found the angles from 0 to 360 degrees. We found the positive angles that rotate counterclockwise. This also says to find the negative angles. So I want to rotate the other way. I want the angle that would be negative. I want the angle that would be negative. Those are coterminal angles, angles that begin and end in the same place. So this last problem here kind of pulls everything that we've done in the first half of this chapter together. So if I have 120 degrees and I want to find its coterminal angle, the angle that goes in the negative direction, I would subtract 360 from it and get -240. Now it's pure coincidence that it happens to be the same value positive. If I have 240, I would subtract 360 to get the negative angle of -120 degrees. So here are my two positive angles and there are my two negative angles. So we used reference angles. The ordered pair on the unit circle gave us that reference angle. And then we also used coterminal angles. That's probably like the most challenging type of problem because it's pulling everything together. Are there questions? Please at home, if you have questions, ask. So those are all the notes that we are going to go over. If you look at your homework, I want to do a problem that's similar to that from the homework just to keep working kind of on the same type of problem. And I think it's 105. So number 105 is similar to this type of problem. Since we just talked about it, let's do another one that's very similar to it. So number 105 is a two-part question. The first part gives us the cosecant, and they're saying the cosecant is 2√3/3. We are going to try and solve this problem the same exact way that we just solved the other problem, except they give you cosecant. Sorry, it's over 3, not 2. And instead of thinking of cosecant, what could we use instead of cosecant? We would do sine. So anytime they give you cosecant, they give you secant, they give you cotangent. Change it to sine, cosine, and tangent. Those are the ones that we use most often. So the sine would be the reciprocal. And when I simplify, I end up with 3√3/6, which is the square root of 3/2. And that's my sine value. So if the cosecant is 2√3/3, the sine is √3/2. Leah, is sine x or y on the unit circle? It's y. So on our unit circle, we have a y value of the square root of 3/2. Jack, when y is the square root of 3/2, the x is, and the angle in degrees that goes along with that is 60 degrees. So that 60 degrees is because my ordered pair is 1/2 square root of 3/2. The directions here say give your angle or give your solutions in degrees and in radians. Find two solutions for each equation. So thinking about the problem we just did, Sign is y. Y is in the first quadrant, positive in the first quadrant. So my 1/2 root 3 over 2, 60 degrees, or if I wanted to write it as a radian, pi over 3. Leah, what other location would my y be the positive square root of 3 over 2? The second quadrant. X is negative, but y is still square root of 3 over 2. That 60 degrees is this angle right here. Whoops, and I wrote the answer. That's my reference angle. I can use that reference angle to find the angle in the second quadrant. If I take 180 minus 60, I end up with 120 degrees. So 120 degrees. And then that's 2 pi over 3. Questions. So that would be like the thought process that you want to think about when you see this type of problem. Does anybody have questions? The other problem that I saw in the homework was number 83. Number 83 is drawing a triangle. If you look at the number they give you, they're giving you the secant is negative 9 over 4. So right away, secant goes with cosine, so that would be negative 4 over 9. Is negative 4 over 9 one of the values from the unit circle? No. So if it's not from the unit circle, then you need to draw a triangle. So it's either on the unit circle or you need to make a triangle. The triangle needs to be in the third quadrant. So third quadrant, make yourself a triangle. Cosine, yes, it's adjacent over hypotenuse, but it's also x over r. So that means my x is the negative 4, my r is 9. Because it's in the third quadrant, the radius is always positive. That means my x value has to be negative. And then I'm taking negative 4 squared, b squared, 9 squared. So 81 minus 16, right? Yeah. What's 81 minus 16? 65? And that does not simplify. So from that diagram, then I would find the sine, cosine, and tangent, the secant, cosecant, and cotangent. Questions? So there are 2 minutes left. Just to take a peek, this worksheet is in your packet. We are looking at page 35, and this is where your review worksheet starts. There are 17 questions. Some of them are pretty straightforward. But looking at number 1 and number 2. Number 1 says find the tangent. Number 2 says find the cosecant. Both of these give you a point and asks you to draw a diagram. So that is my x and y value. You have a point, draw a diagram. Draw a diagram just means draw a triangle. So find the location of that point. Well, I have 7 and negative 9. So my x is 7. That means I'm going over 7. My y is negative 9, so I have to go down negative 9. Your triangle always is created from the origin because it is standard position. And then you would find then the radius of the graph or the radius of the triangle. After you label that value, you're just finding the tangent, which actually you don't even need to know that value because tangent you can find by using opposite over hypotenuse. Same thing with number 2, draw yourself a diagram. This is 8 and negative 7, so over 8 and then down negative 7. So as I said, the answers are on the bottom of the page. Tomorrow we'll go over questions and just kind of review for Friday's test. So I will see you guys on Tuesday actually, next Tuesday. Have a fantastic day.
Miss King, are we coming in Tuesday?
Good day.
Thank you. Have a
Yes,
nice
you're coming in
day.
Tuesday, no, Wednesday next week.
Have a good
Thanks,
day.
you too.